Today we're going to be talking about how to factor binomials and trinomials. So when you think about factoring, you're probably thinking about things like you may have learned in elementary school about like greatest common factor and things like that. So it's where you take a number or two numbers or whatever and you take out the numbers that multiply to get that number. So when we're talking about binomials and trinomials, the factors could be a number or it could be a number with a variable attached. So it could be a full term. So the steps for factoring a binomial or trinomial or any type of polynomial really, you have to find the common factors of the coefficients or the numbers. Also, you have to find the common factors of the variables, the letters. So you take the common factors out, you take the greatest common factor of whatever the terms are, and you put it to the left of the bracket, and you leave the remaining terms inside the brackets. Double check to make sure there's no common factors remaining inside your brackets that need to be removed, and then you're done, and you would check to make sure that you did it correctly by multiplying it out or by expanding, which is what we learned yesterday. So let's do some examples to kind of clarify what all of this means. So here are a couple of binomials and a couple of trinomials that we're going to factor. So let's look at the first one. We have 9x squared minus 18x. So first I have to look at the coefficients and then the variables. What can I take out of both of these numbers? Well, the factors of 9 and 18, the ones they have in common, would be 1, 3, and 9. So I'm going to start by taking 9 out of each term. Out of my variables, I have an x squared and an x, so that means I can take an x out of each term. So to the left of my bracket, I'm going to take 9x. Inside my bracket, so out of this first term, 9x squared, if I've taken out 9x, all that remains is that second x. So 9x times x is 9x squared. So if I take out 9x, I'm left with x. Then I have a negative sign. And if I've taken 9x out of 18x, all I'm left with is 2. I've taken 9 out of the 18, so 9 times 2 is 18, and I've taken the x away, so that's all that's left. So now I can look at my x and my negative 2. There's no other common factors there, which means that there's nothing else I can take out, which means that the 9x is in fact the greatest common factor of these two terms in the original question. And I'm just going to double check that I did this correctly by expanding again. So 9x times x would give me 9x squared, which is good, and 9x times negative 2 would give me negative 18x. So that means that I've done that one correctly. So once this is factored, I get 9x bracket x minus 2. Alright, let's look at the second example. I have 12x plus 4x squared. So what can I take out of both of those numbers? Well, the factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 4 are 1, 2, and 4. So the greatest common factor there is 4. And then I have x and x squared. So I'm going to take one of those x's out. If I've taken 4x out of 12x, I'm left with 3, because 3 times 4x gives me 12x. If I take 4x out of 4x squared, all I'm left with is an x. Now I'll double check my 3 and my x. There's nothing else I can take out of both of those. And I'm going to expand now to make sure I have the correct answer. So 4x times 3 gives me 12x, so that one's correct. And 4x times x gives me 4x squared, so that's correct. Now let's say we have a trinomial like this one, 6x squared minus 12x minus 18. So I have to look now at all three terms. What can I take out of all three of these terms? Well, let's look at the numbers first. We have 6, 12, and 18. Right away I see I can take 6 out of all of those. Now let's look at the variables. I have x squared, I have x, and then this one does not have an x with it, which means I can't take an x out of it. So all I can take out of this trinomial is the 6. So if I take 6 out of 6x squared, basically dividing 6x squared by 6, all that remains is x squared. If I take 6 and factor it out of negative 12x, I'm going to get negative 2x. And if I factor 6 out of negative 18, I'll get negative 3. Again, there's no common factors between x squared, negative 2x, and negative 3. So there's nothing else I can take out. So 6 was, in fact, the greatest common factor of these three terms. And I'm going to check by expanding to make sure that I did this correctly. So 6 times x squared will give me 6x squared. 6 times negative 2x will give me negative 12x. And 6 times negative 3 will give me negative 18, which means that I have done this correctly. Now let's look at the final example. I have 6x squared plus 2x plus 8. Okay, so out of these, all I can take out of each of these terms is 2. I can't take any x's because the 8 does not have an x with it. So the greatest common factor of 2, 6, and 8 is 2. So I divide my 2 out, I factor it out, and I'm left with 3x squared plus x plus 4. Alright, so 3x squared, x, and 4. There's no other common factors there. So I'm going to make sure I have the right answer by expanding again. So 2 times 3x squared is 6x squared. 2 times x is 2x. And 2 times 4 is 8. So I've done that correctly as well. Now we're going to look at some very specific binomials that are called the difference of squares. So in math terms, difference, you may remember, means when you subtract. What is the answer when you subtract? So all of these types of binomials have a minus sign in them. None of them will have a plus sign. If they have a plus sign, if it was something like x squared plus 9, this is not the difference of squares because the plus sign is not a difference. And squares means that x is squared and the number at the end, whether it's this is the standard form of this. A squared just stands for any number a squared. X is our variable, so it's always going to be written as x squared in all of these examples. Okay, so we have x squared and we also have some other number that has been squared. So this number right here, 16 in this example, we can take the square root of that. Or we can think about what number times itself, or multiplied by itself, gives me 16. Well, that would be 4, because 4 times 4 is 16. Or the square root of 16, you'll remember, is 4. So to find the difference of squares, you're going to have two brackets like this. So x squared minus 16 is going to be equal to something like this. You're going to start with an x as the first term in each one. You're going to add one of them, and you're going to subtract the other one. You're going to figure out what times itself equals 16, and we've already figured out over here that that's 4. So we're going to have x plus 4 and x minus 4. These are probably the simplest ones to factor because you just have to think about one step and then write it out like this. So let's look at a few more examples of this. Say we had x squared minus 4, this first example. Well, what times itself equals 4? The answer is 2. So our answer for this will be x minus 2 and x plus 2. It doesn't matter which order, as long as one of them is a negative 2, one's a positive 2. The reason this works is because once you expand these, like you learned yesterday, you end up with this. Because you're going to have, well, let's do that. So we're going to use FOIL again. So x times x is x squared. X times positive 2 is plus 2x. Negative 2 times x is minus 2x, and negative 2 times 2 is negative 4. These two terms in the middle equal 0 because we're adding 2x and subtracting 2x. So all we're left with is x squared minus 4. And that will work for all of these because you're adding and subtracting the same thing in the middle. Alright, I'm going to skip that one because that was the example on the other page. So let's look at x squared minus 25. So we'll start like this, set our brackets up. We're going to have x's in both. We're going to add 1 and subtract 1. Alright, so what times itself is 25? Well, that's 5. So x plus 5 and x minus 5 is our answer to this question. And last example here, x squared minus 100. Well, the square root of 100 is 10. So our answer is going to be x plus 10 times x minus 10, because 10 times 10 is 100. Okay, the last type of factoring that we're going to do is the one that really pertains to quadratic relations. So here's the standard form of a trinomial where a, remember from before, y equals ax squared plus bx plus c is the standard form of a quadratic. Well, in this case, a is equal to 1. So as long as you have x squared plus some number x plus some number, or you could have negative b and negative c there as well, as long as you have this form, I'm going to show you how to factor all of these. So you need to look at the two numbers that you have, the b value and the c value. So let's look at this equation right here. Y equals x squared plus 5 x plus 6. The c value, which is 6 in this example, you have to think about what two numbers multiply together to get 6. So we could multiply 1 and 6, or we could multiply 2 and 3, and that's it. Those are the only factors of 6. Now you have to look at these factors and go, which ones will add together to give you positive 5? Well, if you add 2 and 3, you'll get 5. If you add 1 and 6, you'll get 7. So these are not the ones we want to work with. So when you factor this, you end up getting y is equal to, very similar to factoring the difference of squares, but now the numbers are not going to be the same as each other. So now we're going to have x plus 2, this 2 that we figured out, and x plus 3. So these two numbers that you're writing in the brackets have to multiply to give you this number at the end, and they have to add or subtract to give you this number. And the signs absolutely matter. If, for example, this was y equals x squared minus 5x plus 6, we would have to look at what two numbers multiply to give us positive 6 and add to give us minus 5. In this case, we can't really... Oh, yeah, actually we can. I was thinking of something else. We can. So, factors of 6, we could go 1 times 6, or we could go 2 times 3. So you have to think about positive, and you have to think about negative numbers that will give you 6. So what if we had negative 1 times negative 6? We're still going to get positive 6. What if we had negative 2 times negative 3? We'll still get positive 6. If we add negative 1 and negative 6, we'll get negative 7. Negative 1 plus negative 6 is negative 7. But negative 2 plus negative 3 gives us negative 5. So we can factor this out, and we can have x minus 2 and x minus 3. Because negative 2 plus negative 3 is negative 5, and negative 2 times negative 3 is 6. Sometimes this won't work. This is the one I was thinking about before. X squared plus 5x minus 6. So now we would have to look at what two numbers multiply to give us negative 6 and add together to give us negative 5. Let's see if something works here. Again, factors of 6 are 1 and 6, and 2 and 3. 2 times 3. Alright, so how can we get a negative 6? We could either have negative 1 times positive 6. We could have negative 2 times 3. We could have 1 times negative 6. Or we could have 2 times negative 3. So as long as one of those factors is negative, we'll get a negative 6. Now, is there a way to get a positive 5 by adding these factors together? Well, actually there is. If you have negative 1 times 6, you get negative 6. And if you have negative 1 plus 6, you get 5. So we can, in fact, factor this out so that we end up with x minus 1 and x plus 6. Negative 1 times 6 is negative 6, and negative 1 plus 6 is positive 5. And you can always check this by expanding your factored form again. So once you have it in the form like this, where you have y equals, and then you have x plus, we'll go with 2, any number there, and x plus or minus any other number. This is called factored form of a quadratic. This is standard form, this is factored form. Alright, so let's look at the second example. X squared minus 7x plus 12. So we need two numbers that multiply to give us positive 12 and add to give us negative 7. So factors of 12 are 1 and 12. 2 times 6 would work. 3 times 4 would work. And that's it. So what can we multiply to get positive 12? So they either both have to be positive factors or both negative. If we had negative 1 times negative 12, we'd still get positive 12. How can we do this to get a negative 7 when we add them? Well, let's take these ones, the 3 and the 4, and make them negative. X minus 3 and x minus 4 is the factored form of this equation, because negative 3 times negative 4 gives us positive 12, and negative 3 plus negative 4 gives us negative 7. And one final example here. Alright, factors of 10. We could go 1 times 10, or we could go 2 times 5, and that's it. Those are the only factors. Well, how many different ways can we get a negative 10 by multiplying? So one of these would have to be negative. Negative 1 times 10 would give us negative 10, or positive 1 times negative 10 would give us negative 10. And either the 2 or the 5, one or the other, but not both, would have to be negative to multiply to get negative 10. So that tells me that one of these will be positive and one will be negative. Our x's always go in front. And how can we add two of these numbers to get negative 3? Well, 1 and 10, adding them together, no matter what's positive and negative, we're not ever going to end up with 3. But if we have 2 and 5, we can definitely get negative 3 out of that. So in this case, the 5 would have to be negative, and the 2 would have to be positive. So 2 times negative 5 is negative 10, so that's good. And 2 plus negative 5 is negative 3. So that is our factored form of this equation.